Hey everybody, it's Ripley again, and in this lesson, 2.6, we're going to talk about tangents and velocity. And what we're really going to do is we're going to put some meat on the bones of the limit that we discovered for the last few sections and that you've seen before. By the time we're done, we are going to be able to take any function that's continuous, which we're going to call f of x over here, and we're going to be able to take any point. I'm just going to call this a, okay? And I'm going to be able to figure out what the line tangent is. Now, we already talked about how we're going to do this, right? Remember before how we threw values out here and we connected secant lines, right? Secant lines, and what we did is we dragged that back. So if I call this point right here x, right? And I want to be able to suck this thing back until I get arbitrarily close to the value of the tangent line. Remember how that worked? I'm going to drag x back to a. So let's write this up. If I'm trying to figure out what the slope of this tangent line is, right, because I start with the slope of the secant line, that's what this guy is, and I want to finish with the slope of the tangent line. Well, again, if we remember that whole difference quotient that we talked about before, or the slope of the secant line, I know that this point right here is a comma f of a, and I know that this point up here is x comma f of x. So we've got points, which is wonderful, right? So the slope of the secant line is going to be equal to f of x minus f of a over x minus a, right? And that represents, if you remember, this is the average change of f of x, right? Now what if I want the slope of the tangent line? Well, all I do is take the limit as x goes to a of f of x minus f of a over x minus a. Isn't that cool? And I will get the slope of the tangent line. Now, not only do I have the slope of the tangent line, but remember, we're talking about a point here on the function. So if I have the slope and I have a point, guess what? I have an equation of a tangent line. So let's do one of these just really, really quickly. Let's find the equation of line tangent, tangent, that's supposed to be an e, to y equals x squared at, let's go 2 comma 4. Right? We know that the point 2 comma 4 lives on y equals x squared because I can plug 2 in, square it, and I get 4 back, right? Okay, so now initially this is going to be a little bit tricky to play with, all right? And I know that some of you may have had training in like your physics courses or other classes that you've taken. For now, you're going to have to do these things by hand, and you're going to gripe, and you're going to yell, and you're going to gnash your teeth, and you're going to do all those bad things, but just trust me on this. It's a good experience, and it'll give you exposure to this type of notation, which will come up again in exams and on the AP exam. Right, so let's do this. Ready? The slope of the tangent line is equal to find the equation of any line, I need a slope and a point. Well, I'm halfway home. I've got a point. The slope of line tangent is equal to the limit as x approaches. Now, what are we approaching? Well, we're approaching 2. This is the x value of the point. So it's the limit as x approaches 2 of, not equals, of, well, all I'm going to do is cruise over here, right here, f of x, which is x squared, minus f of a, which is 2 squared, or 4, divided by x minus a. Now, a in this case is 2 over x minus 2. Now, if I take the limit as x approaches 2, oh no, if I try and plug 2 in, bad things happen. I get a 0 over 0. We've done this before. We've done this ad nauseum, right? So I know if I factor, if I turn this into x plus 2 and x minus 2, then my x minus 2's cancel, and I end up with the limit as x approaches 2 of x plus 2, which is affectionately known as 4. Guess what? That's my slope. Now, if I don't ask you for a specific form of a line, you may give me any form of a line. You can give me point slope. You can give me slope intercept. You can give me standard. The easiest one for me, if I don't ask you for one, the easiest one that I think is point slope. Remember this one? This is y minus y naught equals m times x minus x naught. And it comes directly from the equation for slope. If I divided both sides by x minus x naught, then I'd have y minus y naught over x minus x naught, affectionately known as slope. So guess what? I have a point, hallelujah, I have a slope. Even better, hallelujah. The equation of my line tangent is y minus 4 equals 4 times x minus 2. Isn't that awesome? Now, I realize that this may rankle some of you because it's not in the slope-intercept form, which is the function form, right? If I solve for y, then y equals f of x. But if that bothers you, then turn it into a function. Y equals 4x. I get minus 8 plus 4, so I'm going to get minus 4. Now, let's take a gander at this real closely for just a second. Let's see if this makes sense. This is a badly drawn y equals x squared. But out here at x equals 2, I'm just hacking this, so bear with me. This is 2. Then out here, I'm going to get 2 comma 4, right? And just with my sketch, let's see. Look at that. Even with my crappily drawn, I don't know if crappily is a word or an adverb for that matter, but that's pretty close, right? I mean, look at that. That line and that horribly drawn line are pretty close. All right. Now, I would also like to do, I want to examine the other way that we talked. Remember this about slopes of tangent lines. So similar function, we're going to call this f of x, right? And remember what we did? We did this exact same fishing expedition, but we started at x, right? And when we threw out our lure, we came out here to some value x plus h. That's a plus, by the way. All right, and then what did I do? I sucked this thing back just like I always do, right? So this, and I have this, and what I ended up with was my tangent line. In other words, I drew this point back like a bead on a wire, and what that effectively did is it took x plus h and it sucked it back to x. And the way in which that happens is it's the limit as h goes to 0 of, now f of, now remember we dealt with this before, this point right here is x plus h, comma, f of x plus h. And this point right here is x, comma, f of x, right? So if I want to drag this thing back, then what do I have? I take the limit as h goes to 0, because as h goes to 0, this thing goes back to x, and then it's just the slope. Let's talk about that. The difference quotient for this is the slope of the secant line, which is f of x plus h minus f of x, all over, if I take x plus h and I subtract x from it, I get h. If I want the slope, then I just take this guy and take the limit as h goes to 0. And I get the limit as x plus h minus f of x all over h. Isn't that cool? Now, this form and this form are the same thing. They mean find the slope of the tangent line. That's all that it is. Now, think about this. If I'm going to do exactly the same function. So if I let f of x, I won't take you through all of the bloody details, but I will take you through at least the first part. Let f of x equal x squared, find equation of tangent at 2 comma 4. Now think about this. Basically what I'm saying is this is the point which I'm going to call, you know what, we'll do it over here. Let's do, I got to get better with my vertical lines. So I'm trying to figure out the slope of the tangent line out here at 2 comma 4. So really what that says is this x value is 2. All right? So if I'm trying to find, this is the general form for any slope of any line tangent to some function f of x. If I'm looking for slope of the tangent at x equals a, then it's simply the limit as h goes to 0 of f of a plus h minus f of a all over h. So let's see how that plays out. Woohoo! Up here. All right, so first thing, we got a point right here, yippee. Now I'm looking for the slope of the tangent line. I'm going to take the limit as h goes to 0 of, now here's this guy right here. All right, so it's f of 2 plus h. That's all I did. Wherever I saw an x, I put the a, and in this case, a happens to be 2. A is just the value at which we're looking for the slope of the tangent line, right? So it's 2 plus h minus f of a, which is 4, right? All over h, which in this case happens to be the limit, limit as h goes to 0 of 2 plus h squared minus 4 all over h. I plug 0 in. What do I get? Oh, God, I get 0 over 0. Bleh. Unhappy. What do? I do some algebra. This becomes the limit as h goes to 0 of, what is that, 4 plus 4h plus h squared minus 4 all over 4. Well, last I checked, 4 minus 4, those things chunk out, and I end up with the limit as h goes to 0 of 4h plus h squared, over 4. You're supposed to yell at me about that, you guys. That's over h. Duh. My 4's and my h's look terrible, right? All over h. Plug 0 in. Ugh, I still get 0 over 0. Keep working. Do you smell that you can pull that h out? I get the limit as h goes to 0 of h times 4 plus h all over h. Goodbye. Goodbye. This becomes the limit as h goes to 0 of 4 plus h. Oh, look at that. Same thing as we got last time. Isn't that cool?